cylinder with radius 5, kept by a plane, 2x plus 6y plus 3z is 42. So then the intersection says is an ellipse, and we want to find the area. So the projection of the ellipse onto the xy plane is the base of the cylinder. So, and also, if you, like when you project, the major axis is the one that is oriented this way with like the minimum, which has the minimum and maximum on like row values. Whereas the minor axis is going this way, and the projection of that is still going to be the same as the diameter of the base because that's just the distance like across that. Because when you're taking the plane, you're only like shifting like up and down this way. So then you just have to find the ratio of the major axis to the diameter. So to do that, just drew this. This is this angle here. We know the cosine will be 10 over this distance of the major axis. So if you also draw the normal vector of this plane and a vector that just goes straight up, this angle is going to be the same as this because these are both right angles. So just by the properties of angles, you have that. So then, like having n also be a unit vector, you can find their dot product, which is going to equal the cosine. So then, like the where are we at? Yeah. So like distance over 10 is the same as 1 over cosine, which is the same as the area of ellipse over the area of the base, which is 25 pi. So you just have 25 pi divided by 3/7. So 175 pi over 3, so the area of the ellipse. And it seems reasonable, I guess.
I don't know why strong like the projection is going to be the one. So we don't want to allow for the long to be projected. It was all
yeah, something on us here.
Yeah. I think you gave the same expansion factor, 1.7. Or the, so I think cosine, I don't know, I remember finding something over 7. So like, I wanted to ask.
Yeah.
We just straight up say that.
I think that might just be a coincidence.
I don't know.
Because if you had a plane like much steeper,
Yeah.
like as the plane as the normal vector goes like to just like a parallel vector into like the xy plane, the area is going to be so much larger.
I was trying to figure out if there's like a way to find an expansion factor for this, and I kind of tried to do the same triangle, but just in smaller dimensions, though I was not able to recall like anything. But maybe I mean, it seems like you have a better intuition of how these triangles work, like relating upwards. So do you think you could find like one expansion factor for, I don't know, like a little area to a bigger area, given that plane?
Well, that expansion factor should be the same for any projection, I think. Because when you do the projection onto the plane, you're only changing one dimension. Because like if you imagine like in the simplest case like a rectangle, like any other shape will have the same ratio as a rectangle, just because like for like the area expansion factor, but you're only like changing actually the length of like one side of the rectangle, the side that is going to be no longer parallel to the xy plane.
So there which would be like your expansion factor? 3/7.
Well, the expansion factor I think is 7/30 actually, like from the base to the plane.
So if I integrated this circle in the normal plane and then multiply that by the expansion factor, if you get like the same area, that would be like very easy.
By doing integrating what?
Integrate like the circle down and then multiply the same like integral, like every time by the expansion factor. So that way like you're gonna have like more flexibility. Like for example, this works. But for example, if you have like some shape different than a circle, you could like play with that more, or reaching down if you want to project.
should work the solution yet, because area.
Ignacio pointed out that we looked at this before. Do you remember we had a parallelogram on a plane, we projecting it down? We had a little piece of a sphere. We used the cosine of some angle we used to find the expansion factor.
It's like the same angle as this. This is the same approach I used. I said that would work.
Can you explain one more time why 1 over cosine theta is the area of the ellipse over the area of the circle?
Just like from like the basic like the dimensions like changing or like where that came from. Just like you're not confused about like what cosine, like you're not confused about the angle. You just like why.
Yeah, I don't
okay.
Yeah.
Yeah. So we have this this is the major axis, which when projected goes from non-parallel to parallel. The minor axis is still parallel, and the minor axis is just the diameter of that cylinder across, and when it shifts down, it's still that. So we have one dimension changing. So if you imagine that, like, if we just take small rectangles inside it and are adding those up, and like to add this up to get the same effect, we would only change one dimension of the side of a rectangle. So then you would only need the ratio of that one side to its corresponding projection, which would be the same as the ratio of the areas.
Please point to your picture there and show where the 1 is and where the cos theta is, the area of the ellipse.
Yeah, this, or
Okay, so this guy, 1 over cos theta is what? 1 over cos theta. That is this ratio, right? That's length over cos theta. It's the same as area of the ellipse over 25 pi, area of this guy. You should, you have some great work and you say great things, but your arm stays so close to your body. You should,
all right,
you should point to the things more. Good.
so keep that in mind.
You have a perfect picture to explain that quick. So check that we do it again, but I give you a triangle.
Yeah, so we have this triangle here. This is like the major axis, and this is the one that changes. So the factor for like this factor over side of its projection is just 1 over the cosine. So then when that's the same as this area over this area.
So the length of the minor axis is the same in the ellipse as the circle. So it's 5.
Well,
Or was it
10, yeah. Do you want me to draw? So try to draw a picture to make that
Oh,
more
no,
clear.
5. Yeah.
Is there anything else you'd like to talk about?
Let's hear about the helix.
So, with respect to t for each of the different coordinates, so I'll just derive that and then derive that again for with respect to t again. But this is negative sign, so we're gonna have negative